Hello everyone, welcome to EPG Pathshala. I am Dr. Roshan Livingston, working as a medical physicist in the Department of Radiology, Christian Medical College, Vellore. The module that we are going to look today is on film screen radiography. This comes under the wider module which is from radiation biophysics. What is this film screen radiography? Film screen radiography is a branch of radiographic or photographic technique which uses films as a recording medium to record an image produced by an electromagnetic radiation. It can be either from X-rays or from any electromagnetic source. Generally, in radiology, we use X-rays for imaging. So, what happens in this principle? When X-rays hit on a film, the film gets exposed to light through an intensifying screen, or X-rays themselves can produce an image. The X-ray film has certain chemical compounds which undergo subtle structural changes to form an invisible image. When the exposed film is processed using chemicals, it is possible, that is, an invisible image becomes a visible image. So, this has been widely used for more than 100 years throughout the world. But over the years, we see this technique is being transited, and then now computed radiography or digital imaging systems are in place. But however, most rural areas in India still use film screen radiography. So, what is the most important thing we want to see? Let us consider the objectives of this module. It is to understand the basic construction of a radiographic film, to understand the basic construction of a conventional cassette, to understand the basic construction of an intensifying screen, finally to know how an image is formed by processing. What is a radiographic film? Let us consider the basic principle. A film is a thin plastic sheet with a photosensitive emulsion coated on one or both sides of the sheet. Emulsion contains silver bromide crystals which are distributed evenly in gelatin. So, this radiographic film is like a plastic screen where this emulsion can be either coated on a single side or on double side. How we are going to see? Using a film. This is a radiographic film, and this has emulsion on both sides. In some cases, we see the emulsion is on only one side. If the emulsion is only on one side, it can be used for mammography purpose. But mostly we see images obtained using duplicitized films. That means emulsion is applied on both sides of this film. Let us get into detail about the construction of a radiographic film. Let us see the film base. The film base is made out of polyester, which is approximately 0.18 millimeter thickness. What should we consider in a film base? Film base should be transparent, provide support to emulsion layer, transmit light so that image can be viewed, impermeable to water or processing solution, non-flammable, chemically inactive, and uniform in color. Here we see the cross section of a film. Let us see in more detail. The film has a subbing layer, emulsion layer, and a supercoat which is present on top of a film base. What is the subbing layer? It is an adhesive layer between the base and the emulsion. It binds the emulsion layer to the film base, prevents separation of emulsion layer from the base during processing. What is this emulsion layer? Which is very important because it is the active part containing the silver bromide crystal. So, it contains silver bromide, most sensitive part of the detector which produces the image. Supercoat is a thin layer of gelatin applied on top of the emulsion to protect from effects such as pressure or abrasion. Also, there is an antihilation layer. So, what is this antihilation layer? When an image is formed by light from an intensifying screen, some light incident on the film will reach the base. then a part of this light may strike the base and be reflected back towards the emulsion, causing a halo effect as seen in this figure. You may see this black dot surrounded by a lot of minute dots. So that's the halation effect. How do I get rid of this halation effect? A dye is added to the base as an anti-halation layer. The dye is removed when we do the processing. The color of the dye is opposite to the color of the exposed light. For example, yellow dye absorbs blue light, red dye absorbs green light. Let's move on to a conventional film screen cassette. What I am holding here is a conventional film screen cassette. The definition of a film screen cassette is nothing but a cassette is a light tight box which keeps ambient light from exposing the film. The film is placed inside this cassette. The film may have either one or both sides been having the emulsion. If this is a duplicitized film, you have something called the intensifying screen present on both sides of the cassette. For a duplicitized film, this kind of cassette is required. But for a single-sided cassette or single-sided film, we will have only one intensifying screen so that the image quality is better. So, considering this, what we have is a cassette. This is the front side of the cassette. This is the back side of the cassette. Cassette has something called hinges so that you can close this cassette, and inside the cassette is intensifying screen. And there is a place where we can also have a small identification mark in this, where the patient identity is found. So this is about a small film screen cassette. Let's go in detail about the construction of this radiographic cassette. The cassette front. The front of the cassette is designed for maximum transmission of X-rays and is made of carbon fiber or any other low atomic number material of uniform thickness and density. The cassette is designed to allow X-rays only from the front side of the cassette, as you saw in the illustration. What is the cassette back? It has latches which will allow to be opened or closed. The back side of the cassette is lead backed with at least 0.12 millimeter of lead so that the backscatter radiation does not come in. A small access window on the back side present in one corner permits flashing of patient identification on the film. Single-sided cassette has single intensifying screen with single-sided emulsion film used for mammo. Double-sided intensifying screen are used for routine radiography. Now moving on to intensifying screen. What is intensifying screen? As you see in the image illustrated, the function of the intensifying screen is to convert X-ray energy into light energy by a principle called by the principle of fluorescence. What is fluorescence? When certain materials, when it's hit by X-rays or electromagnetic rays, it produces light. This light stops emitting soon after the stimuli, which is X-rays, are also stopped. This principle is called fluorescence. So using this kind of fluorescent material, it is good to produce high quality images in very short duration of time. Screens are permanently mounted inside the cassette on layers of compression foam. The foam produces force that holds screens in contact with the film. Hence, the intensifying screen has a base. Base is made from clear plastic such as polyester, which is 0.18 millimeter thick, provides strong, smooth, flexible support for fluorescent layer, should be chemically inert, uniformly radioparent, and moisture resistant. Then there is a substrate layer. It is a bonding layer between base and the phosphor layer. It may be reflective or absorptive. The reflective substratum maximizes effect of screen by reflecting light into the emulsion. But the absorptive substratum, no reflection by base or phosphor is present, but the screen is lower than reflective layer screens. hence it can demand high doses of radiation. And now we come to the active layer in the intensifying screen, which is the phosphor layer or the fluorescent layer. This is the active layer containing fluorescent materials. Commonly used are calcium tungstate, gadolinium oxysulfate, or lanthanum oxysulfate. In case of this intensifying, we see that the green light which is seen here is because when X-rays falls onto this intensifying screen, it can emit green light. And on top of that intensifying screen, we also put something called the supercoat, which is a protective substance made from acetate. It helps to resist surface abrasion and includes antistatic qualities. It is transparent and water resistive to protect sensitive phosphor crystals. What are the various types of intensifying screen? The speed of intensifying screen actually depends on size of the phosphor grain, addition or exclusion of absorptive material. High resolution, that means slow speed intensifying screens can be used for mammography. This has usually absorptive substratum. For regular medium speed, we have adequate speed and image sharpness, well suited for routine radiography. We use medium speed. Fast speed produces greater blackening of the film. The sharpness is a bit diminished due to reflective layer, so suited for general radiography too. And single-sided intensifying screen are well suited for mammography, where you need better image resolution. Next, we move on to something called the processing of the radiographic film. What is this processing? The process of converting the invisible image or the latent image into visible image is the processing. It is a permanent source of information obtained by a series of chemical reactions. So when we develop, the developed grain results in a speck of silver that appears black on the film. Or changes in the temperature or processing time affects film contrast and density. You can look into that figure. It's a way in which manual film processing is done. Also, it's possible to do something using an automatic film processor. Film processing has 4 steps. One is developing, second one is fixing, washing and drying. And finally, the image after drying is used to visualize on high grade monitors, on view boxes. These are also called light boxes, or view box is an appropriate name. This illustrates film processing. The developer has a lid, then there is a rinse tank which has water, running water can be used, then there is a fixer tank, and then again running water. Then there is an on off switch. Very often we have a small thermostat inside in order to warm up these solutions that are present inside the processing tank. Let us move on to developer, which is the first stage of film processing. Here, the invisible latent image is converted into a visible image. Now, we need to understand this. The entire processing takes place in a dark environment. Once the films are exposed to radiation, that is, they are contained into a light tight box as we saw earlier, they are transported by a radiographer into a dark room. There are various types of dark rooms. In the dark room, manual or automatic processor is placed, and in dark environment, a radiographer opens their cassette, removes the film and feeds it into the automatic processor or holds it into a holder and tries to agitate within the developer. So everything is happening in a dark environment except a safe light is present about 4 feet above the bench where all the processing chemicals are present. Hence, coming to fixer, it converts the invisible image into a visible image. What happens inside? Silver bromide grains affected by X-ray exposure are reduced to metallic silver while those unaffected remains unchanged. The developer solution is alkaline, hence the pH of the solution is 9 to 11. Let us see the ingredients of a developer. It requires a solvent. Water is a solvent where developer constituents can be dissolved. Generally tap water can be used. If the water is hard, water softening agents can be used. The main ingredient in a developer is a developing agent. Phenidone, phenyl 3, pyrazolidone and hydroquinone are used as developing solutions. Then we have other additives such as accelerators. Potassium carbonate and potassium hydroxide are added to the developer solution to maintain the pH. So, the pH should be within 9.8 and 11.4. More than that, we use restrainers. It modifies the behavior of the developing agent and selective in their action. Potassium bromide is used to reduce the tendency to convert unexposed silver from micrograins to silver and prevent chemical fogging. There are also preservatives used. Potassium sulfide is commonly used to reduce oxidation of developing agents. Important thing is temperature. In some cold places, we need to warm up this developer solution, and then generally it is between 30 degrees to 35 degrees or even from 25 onwards for good developing. So, in automated machines or automatic processors, temperature can be adjusted based on type of imaging performed. Maintaining a temperature between 38 degrees centigrade and 42 degrees centigrade, it takes about 90 seconds of processing time using an automatic processor. But there it increases the image density, increases chemical fog and image contrast. But if I reduce the temperature and maintain it as 30 degrees centigrade, the reduced chemical fog can happen. It reduces chemical fog and it also reduces image contrast. This is all possible in this automatic processor. The next stage is also the time, which is important. We talked about temperature, time is also important. The time interval between entry and exit of the film through the developing solution is called developing time. Cycle time is another thing, which is the entry and the exit of a film. This is usually seen in an automatic film processor. For a cycle time of 90 seconds, a developing time is about 26 seconds. For 110 seconds of cycle time, developing time is about 30 seconds. What are the factors that govern development time? That is, one is activity of the developer, type of emulsion and agitation of the solution. These are the factors that govern how good the film is going to be developed. Next, we move on to a film processor, which is the fixing. Can be the final stage, so that we are going to fix what is present in the film. Fixing stops any further film development, clears the image by removing the remaining silver halide, fixes the image so that no further changes takes place, completes the process of hardening of the film emulsion, and now fixer is acidic, hence the pH is from 4 and 4.5. Very close pH should be there, that is between 4 to 4.5. Let us consider what are the various constituents of a fixer. Fixer also has solvent, which is water is a solvent used in fixing solution. It controls the activity of the fixer by diluting its effect. The fixing agent is a chemical which washes the insoluble silver halide in the film emulsion, does not dissolve metallic silver. What are these fixing agents? They are nothing but sodium thiosulfate and ammonium thiosulfate. Fixer also has hardening agents. The function of the hardener is to reduce the drying time and prevents physical damage. Aluminum chloride and aluminum sulfate are commonly used hardening agents. It also has preservative such as sodium sulfate, used as a preservative to retard the decomposition of thiosulfates. There are also anti-sludging agents. Aluminum salts have the tendency to produce insoluble aluminum compounds, may form sludge which adheres to the film and sides of the fixing tank. Just like how we have the salt in the buckets which we use for our washrooms. If there is more salt, we will see the deposition on the bucket. Hence, to avoid this, boric acid is used as an anti-sludging agent. The activity of the fixer agent increases with temperature. So, when we use high temperature, it speeds up the process of diffusion and the emulsion containing gelatin. It is also more susceptible to damage when you go for very high temperatures. The higher temperature difference between developer and fixer may result in films suffering emulsion damage. Something like breaking of the emulsion takes place in the film. Finally, we move on to washing. So, when a film leaves the fixing tank, its emulsion is saturated with fixing solution now. This is contaminated with silver complexes and ammonium halides. If such chemicals are not removed, the emulsion will gradually acquire a yellow-brown sulfur stain during storage, because we have to think about storing these films long term, that is archival. So, hence we need to clear whatever is unnecessary in the film. Generally, tap water is used, running water can be used as a washing medium. And then we move on to the drying. Drying is the final stage of the processing cycle. So, after we dry, we have a good radiograph which can be seen by the clinician. So, during drying, it removes the surface water, most of the retained emulsion. Some moisture must remain in the emulsion to prevent it from becoming too brittle, otherwise it will start breaking. So, water is removed by squeegee rollers in case of films which are developed using an automatic processor, while evaporation removes the water from and within the emulsion. But in case of manual processing, it just dries up. We can also have a coil, a heated coil and a blower to dry up this kind of films. In some cases, they hang it under the fan for a long time, for half an hour or so, and it dries up. And finally, the film, which is the detector, is ready for visualizing by the clinician. I hope you understood this module on how films are constructed, a cassette, intensifying screen and the processing cycle. To be more precise, in a processing cycle we have developing, then we have rinsing, fixing, washing and drying. Let us summarize what we have looked through this module. Film screen radiography uses a light-tight cassette containing film and fluorescent material to record an image using X-rays. Film is the recording medium or it is a detector. When films is exposed to X-rays, chemical compounds in the film undergo subtle changes to form a latent image. When film is processed using chemicals, it is possible to visualize the invisible image into a visible image. The use of intensifying screen is to convert X-ray energy into light energy by the principle of fluorescence. To get maximum film blackening from least radiographic factors, films need to be matched with intensifying screens. More precisely, the color of the intensifying screen. It is important to maintain the pH for both developer as well as the fixer. Temperature of the developer and fixer are very important and crucial in chemical processing of the film. I hope you understood this module. Thank you for your patient listening.